To demonstrate this, we'll use nested lists, with the inner list serving as mutable objects. Here's a list containing two elements, each of which is itself a list. Let's look at what's going on under the covers as Python constructs this data structure. First, two integer objects are created containing the values 1 and 2 respectively. The elements of the first inner list are references to these two integer objects. Now, two more integer objects are created containing the values 3 and 4 respectively. The elements of the second inner list are references to these integer objects. Now the outer list is created, its elements containing references to the two inner lists. Finally, the reference named A is bound to the outer list. What happens when we copy the list? Here we use the full slice technique, but any of the three techniques we've shown will have the same effect. We're requesting a copy of the outer list, so its elements, which contain references to the two inner lists, are duplicated. These references refer to the same inner lists as the original list A. Once the list copy is complete, we bind a new reference named B to the new list. We can confirm that the lists are distinct objects by testing with A is B, which returns false. They do, however, contain equivalent values, which we can test with A equals B, which returns true. Not only are the elements at A0 and B0 equivalent, they actually refer to the same inner list object. Now let's replace the element at A0 with a new list containing 8 and 9. This results in the construction of two new integer objects containing 8 and 9 respectively, and a new list, the elements of which are references to these two new integer objects. The reference in A0 is redirected to point to this new inner list object. And we can confirm that A0 now indeed points to the new list, whilst B0 is unmodified. What happens if we now append to the inner list referred to by A1? Let's append a new integer object containing the value 5. The new integer object is created and is referred to by an additional element in the inner list referred to by A1. So A1 now refers to a list containing integers 3, 4, 5. Significantly, because A1 and B1 refer to the same inner list, the list accessible through B1 has also been modified. Following these manipulations, the data structure referred to by A is a list containing two elements, each of which is itself a list. The first inner list contains 8 and 9, and the second inner list contains 3, 4, and 5. The data structure referred to by B is also a list containing two inner lists. The first element refers to a list containing 1 and 2, and the second element also refers to the 3, 4, 5 list.